Okay, so they want us to factor this one. So here now it's of the form x squared, x, no x. So we know what we do with that. Multiply, add, multiply, right? But this one, we've done these before, we've done a lot. We have done multiply, add, multiplies, yes, but this one's going to be quite a bit harder. Why? Because it has a number in the front that does not factor out. So in other words, your first step should always be, first is you try to find a GCF that's in common, which is really like stuttering, greatest common factor in common. I'm saying the same thing twice, but I'm just trying to be clear, right? There is no greatest common factor here. There's nothing. What do these three have in common? Nothing. There's no number they all share. They don't all have an X. The two at the back doesn't have an X. There's no number they all share in common. There's no number in the middle other than 1. So no, there's no GCF. But on some of the other ones, there will be. I just want to get you in the habit of first trying to say, is there a GCF? Okay, no, on this one, there's not. So then I'm going to go right on with multiply, add, multiply. So how do I do it? You do the 2 parentheses, right? And you say, okay, so make it a little smaller. 2 parentheses. And you do front times front to make front. Multiply. So what times what makes 6x squared? Well, 3x and 2x, huh? That's not too bad, right? 3x times 2x, right? Out front numbers multiply powers, and there's invisible 1 powers on those x's. So 3 times 2 is 6, and the powers had to be squared. Now, should you put the 2x first and then the 3x? Well, it doesn't really matter which ones you put first or second, but it will matter who goes with whom. I'll show you in a second. So now, what do we do next? Well, now we look back here. Don't worry about the middle. We'll get to that middle -1 in a second. Now go back to, okay, what multiplies to be -2? Or let's just go with 2. What multiplies to be 2? 1 and 2, right? I mean, what times 1 is 2? Well, it's only 1 times 2. There's really not any other options. So it's 1 times 2. But that's the wrong answer. What do you mean that's the wrong answer? I'll prove it in a second. Why? What other options could there be? It's just 1 times 2, right? Yes, it's just 1 times 2, but now it matters because the fronts are different. They're not the same. They're not just XX. This is the difference. In all the other ones we did, the fronts were just XX. So who cares what order on the back? But now it matters because does the 1 go with the 3? Or should the 2 go over here with the 3 and the 1 go with the 2? It's going to matter. So we have to try it in both orders. Let me go over here and do it in the other order. So the other order, which will actually be correct, 3x, 2x, I'm going to put the 2 here and the 1 there. See how I reverse that? The 2's going with the 3 now, and the 1 with the 2, instead of the 1 with the 3 and the 2 with the 2. Well, how do you know which is which? And by the way, I haven't put any pluses or minuses in yet. There's just too much going on. Let's first get straight where they go, and then we'll put the signs in later. Well, how do you know which one of these is right? You got to check it. You've got to check them both. So let's check them. So that's what's harder on these. You have to check them. They take more time. You have to check them because there's options for the orders. Everybody see the main issue? When the fronts are different, it matters what order you put the backs in. Let's see it. How do you check? You know, first to both, second to both. Huh? That's how they multiply without any signs. Just forget about signs. Just 6x squared. What's that? 6x, 2x, 2. Okay, so what am I checking? I'm checking the middle 2. Can those middle 2, the 6x and the 2x, with pluses or minuses or whatever, somehow make the middle term adding or subtract to be -1? No way. 6 and 2 add to be 8. They subtract to be 4. There is no way they're going to make -1 in the middle. This is not possible, which means that's the wrong answer. Let's go over here and check this one. First to both, second to both. What do we get? 6x squared, 3x, 4x, and 2. Now, again, look in the middle. Can these 2 in the middle somehow make the middle term of -1x? Yes, they can do it. watch this. Don't miss this. This is super important. This is the part that's sticky. How can they do it? How can 3x and 4x make the middle term of -1? What's the rule we've learned? Sign in the middle. So you've got to know this. This is bread and butter for you. This is life and death on these factoring problems. Sign in the middle, meaning right there in the middle of the original, goes where? Goes to the bigger. So you got to take that guy. Which one of these is bigger? The 4. -4 plus 3. Did you see that? -4 plus 3 makes -1, doesn't it? 3 take away 4 is -1. If you gain $3 and then lose 4, you lost 1 on your stock or whatever, right? Up 3, down 4. The running back gains 3 yards in the first play, loses 4 in the next. They've lost 1 yard overall, right? You with me? Sign in the middle has to go to the bigger number. Now, you might say, yeah, but Mr. Harris, it's still not in the parentheses. Right, here comes this trick. Don't miss this. A lot of things not to miss on these. They go reverse back to the parentheses. Crisscross. Did you see that? Why? Because same reason anything else in math. It's true. What do I mean it's true? How's it true? Look, -2. How does this, what does this -2 do when you multiply it? -2 times 2x makes -4x. And what is this +1? Look at his arrow. +1 times 3x makes +3x. See, it's just true. And there's our answer. And we know it works because we checked it right here. Oh, and by the way, the last one, -2 times +1 does make -2, which is perfect, -2. It checks. So let me run over that one more time. There's a lot going on here, and it takes practice and concentration and organization. You got to be careful. You can't be kind of like everywhere. I'm a very sloppy writer, as you see, but I make things big enough and careful enough to where I don't lose myself. So you don't have to be a clean writer. Obviously, I'm not. But you do have to keep it organized. You got to keep it organized and make it big enough so you can see it all. So one more time, what just happened? When you see x squared, x, no x, you go multiply, add, multiply. Put the 2 parentheses. Front times front to make 6x squared. That'd be 3x and 2x. And then what multiplies to be the back? 2, 1 and 2, but there's 2 possible orders. 1 and 2 here, or 2 and 1 there. And then you just check them. You check them in both cases, and you find the ones that can make the middle 2, make the middle. That's the hardest part. The middle 2 have to make the middle. 6 and 2, 6x and 2x cannot make -1x in the middle. But 3x and 4x can. How so? Sign in the middle goes on the bigger. So -4 plus 3 does make -1 in the middle. And then how do they go back to the parentheses? They crisscross. Because that's what's true. If you track them, that's how they got there. And so that's our answer, just like that. And it's being proven by the check. Is that making sense on that? So that's, so then now let me give you one more tip that can actually speed you up, that you don't have to check so much, which I'm sure you would like to not have to check so much. Write it down here. There'll never be 2 numbers in the same parenthesis that have anything in common. What do I mean? You see back here how the 2 and the 2, I was trying to put 2 2's in the same parenthesis. If I'd been aware of this rule, I would have right away just said, oh, no, no way on that. No way. You're never going to have 2 numbers in the same parenthesis that have anything in common, let alone are the very same number. Not going to happen. Not going to happen. So, for example, you can't have a 2 and a 4 in the same parenthesis. They have 2 in common. 2 goes in. You can't have a 2 and a 6. You can't have a 4 and a 6. Why not? Because 2 goes into 4 and 6. You're never going to have 2 numbers in the same parenthesis as an answer that have anything in common. Why not? Wonder why? Is that just Mr. Heron's rule? Yeah, nobody knows why. It just always turns out that way. No, there is a good reason. It's because if they had anything in common, then you could factor it out. So for example, if you had 2x plus 4, right? Then you could factor out the 2. It'd be x plus 2, right? Well, so what? Why does that take us a little? Well, you would have done that earlier. That's step number 1. Step number 1, we take out what's in common. So there can't be any commonness showing up later. It can't happen. So that'll speed you up if you're aware of that. When you're looking at possibilities, you won't even waste your time trying 2 and 2 in the same parentheses. No way it's going to happen. You'll jump right to the other option. Does that make sense? So it's all about 1 times 2 makes 2 at the back, but you've got to try in both orders. 1, 2, and 2, 1. Check them, see which one works. And it's all about the sign. Sign in the middle goes in the bigger, then crisscross them back to the parentheses. There we go.